People here and will not be able to get into to many details of the not disclosed stuff, but I guess that about strictly technical aspect of the and not undercover aspect of the accident, he can give some insight and some interesting answer about that. Thank you very much to Jameson for being here.
Yes, while I'm unable to give any specifics about the Bitfinex hack, other than what's already been publicly disclosed, if you pay really close attention, you might pick up a few clues throughout the presentation.
Please around.
Yeah. So I'll basically start off with a bunch of security stuff because that's, of course, what we focus on. But then I'll go into more depth of things that I've personally learned over the past year and a half working full-time on a Bitcoin wallet. Just technical issues that come into play when you're managing a high-volume, high-security Bitcoin service. And as he said, my name is Jameson Lopp. I became interested in Bitcoin in 2012, and I, after a few years, created Satoshi, which is a fork of Bitcoin Core, only about 300 lines of code on top of Bitcoin Core. And all that it really does is it outputs a lot of metrics from internal node operations, which you can then visualize with various software, which you can check out here at satoshi.info. I was basically trying to bring a DevOps mindset to the operation of Bitcoin nodes. And I think it's gone pretty well. Satoshi has been referenced by a number of Bitcoin Core developers like Gavin Andresen and Mark Friedenbach, and I think it's helped some of their own research when trying to better understand how the network operates at the node level. So for the past 18 months, I've been employed by BitGo, and we are a Bitcoin multi-signature wallet. We power a lot of the Bitcoin exchanges. So we'll start talking about security, and as you're probably well aware, Bitcoin is very difficult to secure. And this is because Bitcoin is a bearer instrument. Essentially, it means the bearer of the private keys is essentially the owner, and they have the right to transact on the network. And of course, there's also the irreversible aspect of it, where unlike what you see with like the Federal Wire transfer system or a number of other traditional banking systems, you can't undo a transaction once it has been confirmed. So this results in some interesting problems, but the result for the way that we like to describe it is that Bitcoin is one of the most slippery substances in existence because it can be taken from you in a matter of milliseconds by a remote attacker, and you have little to no hope of recovering it once it's gone. So cold storage is arguably one of the most secure ways to keep your Bitcoin from taking away from you. And this, if you're not familiar, means that you generate the keys offline on a computer that never touches the internet, so it's not even possible for a hacker to get the private keys and steal your Bitcoins. And you could argue that the only truly secure key is a cold key. There's a good argument for that position. Though you could even take it a step further and say, maybe really the only truly secure Bitcoin or secure key is one that you have deleted. Because even cold storage has to exist somewhere physically. There has to be a way for someone to get to it. Of course, physical security can be a lot more difficult than internet security for someone to compromise. Now, the biggest benefit of cold storage is that it eliminates an entire class of online threat vectors, and it brings us back to the realm of physical security, which is something that humans have been dealing with for thousands of years now, so it's been pretty well owned. But relying on physical security is not perfect either. I mean, you still have jewelry heists, the occasional physical bank robbery. There's really no such thing as perfect security unless you have locked down an asset to the point that no one can access it. And being able to access assets, of course, is what makes them have utility. So there's this old saying that a ship in port is safe, but that's not what ships are designed for. So is Bitcoin really best suited to be stored, locked away in a vault where no one ever accesses it? Some people might argue that it is essentially a digital gold. It's definitely debatable, but I think that in order for the Bitcoins that are sitting locked away in these vaults, we have to have a bunch of other people who are using Bitcoins in hot wallets for a number of different purposes, whether that's buying, selling, trading, or doing other things like time stamping, other types of data services on the blockchain. And so as a result, it means that we need to have a way for Bitcoins to be secure and accessible. So we at BitGo believe that Bitcoins need to be moving around. I mean, we facilitate a lot of exchanges like Kraken and Bitstamp and Bitfinex, and probably dozens of smaller ones that I'm not even familiar with. So as a result, these exchanges generally have a hot wallet, cold wallet setup. The hot wallet is really what is kept online, handles the deposits and the withdrawals, and is a tiny fraction of what their total Bitcoins are. Moving funds from the hot wallet to the cold wallet is very easy. You just make a Bitcoin transaction. But moving from the cold wallet to the hot wallet, much more difficult because you add layers of physical security that require human interaction, tend to be much costlier from a time and resource standpoint because they're meant to be much harder for anyone to access. This is all good and well. It reduces the amount of exposure that you have, but it still has some downsides. So if you're running a hot-cold wallet, one issue, for example, is that you're pooling the customer funds together. This could be a problem if you want to use the blockchain to segregate the ownership of your funds. There are a lot of different use cases. Some services want this, others are fine with a pooled wallet. Second, the hot wallet itself may still be quite large. So if you have hundreds of thousands of Bitcoins, even if you're only keeping a small 1 or 2%, that hot wallet is still a fairly significant amount of money. So you want to be able to secure it as well as possible. And then even if the hot wallet is small, it can be a matter of really the flows of the Bitcoins in and out. So for example, if you have a hot wallet that gets compromised, and I think this happened to Bitstamp a year or so ago, you have mitigated the loss to a small percentage of your existing Bitcoins that you held. However, all of those addresses in the hot wallet whose private keys have been compromised, now the attacker continues to drain money as unsuspecting users continue depositing into those same addresses. So the actual hack can continue for many hours, if not days, before everyone learns that they need to stop using anything related to that hot wallet. And then cold storage wallets also have just more complexity to them. There is still insider risk. So you're creating a lot of additional obscurity by creating security processes that are internal to your company, but you're also generally having to trust some certain people, usually operations or C-level executives, to managing that cold storage. So sort of going back to cold storage versus multi-sig, we definitely believe that there's still a large role for cold storage, but that it's actually best used in conjunction with multi-sig. So these are two orthogonal security techniques, and if the more security that you can apply, of course, the better off you're going to be. So instead of just using one or the other, we actually prefer using both at the same time. So multi-sig improves cold storage in many of the ways that it also helps you secure your hot wallet funds. Because of the flexibility of how you can set up multi-sig and how you can set up cold storage, it's really hard to say that there's one specific solution that's the best solution. You really have to tailor it for your business needs. So, if you're not familiar, here's a simple chart of 2 out of 3 multi-sig, which is essentially what Bitcoin does, or BitGo does. You could consider us the signing oracle down here, and these are the 3 different keys. The user will have one key in some sort of hot wallet software, and then a backup key that could be held by them or by a third party, and then the oracle has the 3rd key. So you need 2 out of those 3 keys in our particular setup in order to construct a valid Bitcoin transaction. The difficulty with Bitcoin security is that with your standard pay-to-public key hash transactions, you have one key, and that's your single point of failure. It's kind of like running, using Gmail without 2-factor authentication. Like, you only have one password, and if anybody gets that one password, they now have all of your information in your email account. So we could kind of think of having a second key as a form of 2-factor authentication. But as I mentioned earlier, multi-sig is not just a box to check. It's not a silver bullet. And listen carefully here, if you implement multi-sig badly, you can actually increase your attack surface as opposed to decreasing it, which is of course what we're trying to do. So it's just another type of technology, and it's all about how you use it. If you're using it incorrectly, it can actually be detriment, terrible for you in the long run. So I guess the question is, how should we do it? Well, we recommend looking at risk rewards. We can sort of start off with some of the different risks in general. For example, if the user holds the key, security risk is malware, and we've actually seen a fairly large amount of customized malware that is being specifically created to target Bitcoin users to get their private keys. So of course that means if you have private keys on your computer and any type of malware that's looking for them gets on there, you've lost everything. There's also the problem of weak passwords. And humans are very, very bad at creating passwords. Of course, there's LastPass, KeePass, and other password managers out there, but from me asking my friends, I really don't think that many people outside of like this type of security crypto community use that type of management software. Then, of course, there is coercion, which I'm not aware of any big thefts that have been caused by coercion, but it is, of course, still a risk that exists.
Ross Ulbricht theft.
Yeah, that's a good point. That's a good point. Something that a lot of Bitcoin users don't think about is, what happens if you die. Coming up with a proper way to ensure, non-technical heirs can access your crypto assets without increasing your own risk of loss can be very challenging, and multi-sig can help with this. Of course, data loss. There have probably been hundreds of thousands of Bitcoins lost from data loss. And the downside, the forgotten password. So if a user does create a really strong password and they're not using password management software, they can very easily forget it and once again lock themselves out of their own assets. And I've heard quite a few stories of people that have had that happen to. So what happens if we have a remote service that holds the private keys? It could be a shared wallet, it could be like a Coinbase or a Circle, some sort of custodial service. So malware is still a factor, though possibly not as much because you would assume that they would have competent people who are managing their servers. Hacks are a much bigger attack vector than individuals because you're pooling lots of money together on a small number of machines. Actually, insider theft, which we saw recently with Shapeshift, and there have probably been several others that weren't ever told to us that were insider theft. Services can also either purposefully or accidentally turn into fractional reserves due to theft or other malfeasance. And of course, government seizure. So you actually have to worry about what country the servers or the company is domiciled in, and figure out whether or not you trust the government not to screw with that. So there can also potentially be data loss if they're not a competent business. And if anything happens to the service, they might be DDoS, they might have some sort of terrible technical failure that causes them to go down and they don't have backups, then they could even lose access to your private keys. And then finally, we have phishing, which seems to be getting worse and worse over time, just for all tech companies in general. Even if you just have data that is interesting to hackers, there will be social engineering attempts against your own company's employees to try to get it. I know that we get spearphished on a pretty regular basis, and of course we have training to help guard against that. So what happens if we change the or here to an and, where the user holds the key and the service holds the key? This would be a 2 of 2 scenario. I believe this is a green address model.
The full model.
Yeah.
They also have two.
So in this case, both the user and the service have to sign the transaction in order for it to be valid. On the user side, we completely eliminate a whole host of threat vectors, because if any of these happen, then the service will hopefully refuse to countersign. This is, of course, assuming that the service is requiring some sort of two-factor authentication, additional requirements before countersigning a transaction. And on the service side, we've eliminated a whole class of vectors here because the user is not going to sign off on a transaction if any of these things occur. If a user suddenly gets asked to create a transaction when they're not wanting to, they're just hopefully not going to sign off on it, and that will prevent theft from occurring. And the nice thing is that fractional reserve is also impossible because the funds can no longer be pooled into one big pool. They have to be kept segregated. And of course, if you're afraid of government seizure, then unless the government also comes to your house, then you're probably going to be fine. But notice that on both sides, we've still got a few issues left that could result in loss of funds. So what do we do about that? We found that adding a third key to this will actually allow you to get rid of some of these additional vectors. So leaving aside for a moment the question of who holds the third key, on the server side, we get rid of all the problems on the user side because now you have a backup third key somewhere, which of course, hopefully, you're securing correctly. On the server side, we eliminate all of these except for phishing. And phishing is particularly tricky because it ultimately comes down to attacking the weakest part of this entire ecosystem, which is the humans. And I guess that's kind of what security is all about, is trying to get the humans out of the equation as much as you possibly can because they can be fallible. So, as noted though, it's it's complicated, and there is no single best solution to any of this. For us, we actually tend to consult with the companies that we bring on to help tailor their solutions to them as much as possible. Sort of moving on past security though, one thing that I've been working on for pretty much the entire time I've been at BitGo is our low-level blockchain indexing service. This is basically how we keep all of our databases in sync with the current state of the Bitcoin ledger. And this would be, for example, noticing which transactions belong to BitGo users, updating balances. We found that we have to do this all with our own custom software because trying to use Bitcoin node to manage hundreds of thousands of wallets just does not scale. And there are a lot of queries that we want to be able to slice and dice the data in different ways, which requires additional indexes that are not supported at the native Bitcoin level. So this is really what all of the blockchain services out there are doing, is they're running their own software that's using MySQL or like a distributed key value store, HBase, Mongo, Redis, any number of these. We've actually found that non-relational databases work pretty well because almost everything is single hash lookups. And I've come to find that while processing a static blockchain, which you've got your blockchain and each block has a transaction and it refers back to other transactions, processing a blockchain on its own is pretty simple. But trying to process a blockchain very quickly, if you want to do the entire history of the ledger, you run into performance issues. And also trying to keep it up to date with all the unconfirmed transactions poses a number of additional challenges because people are trying to do bad things on the network. You're probably very familiar with this type of data setup, so I don't have to go into too much detail with that. So, when you're processing a blockchain, you want to start from the beginning and work your way linear to the end to make sure that all of the inputs and outputs connect. This is simple to code, but if you want to do it quickly and you want to parallelize it, you run into a lot of problems because you very quickly sort of branch out into these huge trees of workers that right now we have 150,000 or 150 million transactions in the Bitcoin blockchain, and the best that I've been able to get like a single beefy machine to process this entire blockchain into our own database, which has dozens of indexes. I'm constantly battling with like a 24-hour period. And it's getting worse and worse, and I'm always having to find more and more performance improvements. I have some ideas for sort of drastic overhaul of that, but it would require a complete rewrite of our service. So the problem with parallelizing it is that you get workers that start getting really, really far ahead of, I guess, what the block that you're currently processing. So we generally process like one block at a time and parallelize transactions within the block, but even within a block you can have many, many transactions that are dependent upon each other. So you get a lot of blocking operations going on. Now with indexing of like the real-time unconfirmed transactions, some of the biggest problems that I've run into are what you see here. Reorganizations are definitely a major event on the blockchain. When you see a reorganization happen, you basically have to stop what you're doing, roll back all the transactions in reverse sequential order back to wherever the common block of the fork in the chain is, and then you have to roll back forward on the new chain fork. So while you only really see about one reorg per day on the main Bitcoin blockchain, and it's usually only one block, so a few thousand transactions, not a big deal. I've seen block storms on testnet that have had tens of thousands of blocks, as you can kind of see in the spikes here. So this is a big issue if you're running on testnet, which everyone should be doing, because a lot of the software out there, like Bitcoin J, for example, only keeps track of like the past 100 blocks or so. And if you're on testnet and you get a 1,000 long block reorg, it'll just break Bitcoin J and your service will stall out and you'll have to go in and manually fix things. So the first time that these block storms started happening, it actually broke half of the public testnet blockchain explorers. Probably because most of them were using Bitcoin J or some other derivative that had this particular problem. The reasoning behind why this can happen is actually really obscure, but there's like a special rule on testnet where the difficulty will reset to 1 if there isn't a block for 10 minutes, and if you do that at the same time that the difficulty adjustment happens, then you can permanently set the difficulty back to 1. Then people are off to the races and mining like 10 blocks per second. And of course, everybody on testnet's doing that, and you get the crazy reorgs going on. I think that Block Trail had a really interesting write-up about how that particular issue happens. Now, double spins are also easy to check for, but if you come across a confirmed transaction in a block that conflicts with an unconfirmed that you already have indexed in your database, now you have to go like unwind all of the ancestors of that before you can apply the new changes. It's once again, you get into this issue of lots of trees, which is very bad when there are spam attacks on the network, which I'll show you some graphs of in a little bit. And then lastly, some issues are that some transactions actually never get confirmed, and so we have cleanup operations that go and find week-old transactions and prune them automatically, because otherwise we can have customers that end up with unspendable bitcoins because of the way that this works. So if you're familiar with the unspent transaction output set, this is the Bitcoin, right? So there's no such thing as a Bitcoin. There are only unconfirmed transaction outputs, and they have values on them. And basically what I'm trying to show here is this tree structure. So when you're running an indexer, it has to be bulletproof, it has to be perfect. If you miss a single transaction, then it will very quickly corrupt your data. So like if something happened and you dropped the ball and you didn't finish indexing this one, for example, then all of these transactions afterwards are going to be either wrong or non-existent because you think that they're invalid because you couldn't find the inputs for them. Basically, I spent probably 6 months just working on writing sort of test suites that used the regression test mode of Bitcoin. So I would spool up a lot of local Bitcoin nodes, create the crazy blockchain forking situations, and make sure that my service didn't drop any of the transactions and that it did roll back the ones that it was supposed to. Because whenever you run into that problem in production, all of a sudden you're scrambling to figure out how you repair your corrupt database. And your worst case scenario, you fail over to a different database that was hopefully running a slightly different version of your code that didn't have the same bug or didn't have the same hardware hiccup or any number of other things that could cause a database write not to occur. So I'm pretty happy with the current state of our indexer service. More scalability issues are looming, but The sort of idea that I'm playing around with right now is, instead of rolling through all of these blocks and transactions sequentially, instead we could use a sort of MapReduce style processing, where we would actually be able to do multiple phases of checking all of the inputs of the transactions, and then a secondary phase of adding up all of the balances, because unfortunately there's no fees in the actual blockchain data. You have to figure them out yourself. This is why you can't just process a block in the middle of the blockchain. You have to know what the values of all of the ancestors were to figure out what the fees were. But by doing a MapReduce multiple phase parallel processing of blockchain data, that would give us like true horizontal scaling, where you can just throw more machines at it, and if you want to pay enough money, you could probably process the whole blockchain in 10 minutes or 20 minutes. If you have hundreds or thousands of workers that are parallelizing. Related to unspent outputs, once you have a service that's actually keeping track of them all correctly, if you're operating as a wallet and helping people spend the unspent outputs, then you have to write an algorithm to decide how to choose which ones to spend. We've expended a lot of our engineering resources continually fine-tuning this particular part of our wallet. And it's due to the flexibility of how you can choose the unspent outputs. You want it to be really easy for the user, where they're just saying, send X Bitcoins to address Y, and all of this happens under the hood. But what you have to do as a service is sort of look at the user's history, like how they're using their wallet, look at a number of different attributes of the unspent outputs in their wallet, and figure out like what the best way to optimize the current state of the outputs in their wallet, so that it won't get them in a bad state in the future. Some examples: the naive approach, which wallets did very early on, is you simply look for the smallest output that exists in the wallet that is larger than the value they want to send, and then spend that. Otherwise, you just start adding up the next largest outputs until you have enough money. This seems like a straightforward way of doing it, but what it results in is a fracturing of all of the outputs in the wallet, until you have this wallet that has thousands of tiny little dust values of outputs, which are essentially unspendable, because of course you have to add fees to your transactions as you add more inputs. SegWit will help with this a little bit. Bitcoin can contain hundreds of inputs and outputs. We make people spend a fee sort of as an anti-spam measure, so that the more block space they're using with transactions, the more they have to pay. These are only like 3 of many different ways of looking at a wallet. I would say most wallets probably try to minimize transaction fees. Number 1 is not particularly great for the user, but it's sort of being a good custodian of using a blockchain. Number 2, there are a couple of wallets that focus on privacy, and there's actually a open blockchain privacy project that I've participated in a little bit. Privacy becomes a very complicated issue unto itself, but the problem with any of these is that if you choose one, you're making trade-offs with any of the other ones. So if you're really going to offer a wallet that keeps users happy, then probably the best thing to do would be to let the user decide how to optimize spending from their own wallet. Because some users care more about transaction fees, some care more about privacy, et cetera, et cetera. That was the spam attacks that I was referring to. This is the total aggregate sum of all of the Bitcoins in the UTXO set. But as you can see, it's a constant uptrend, which is why I also try to tell people to be good stewards of the blockchain and try to prevent blockchain bloat. Because the implementation choices are up to engineers, I basically, whenever I talk to engineers, I say, this is a shared resource. Everyone that's running Bitcoin has to use this hard drive space and then other computational resources. Last I checked, there are 41 million UTXOs and about 1.3 gigabytes of compressed serialized data. If you're trying to hold all of those in memory, which miners prefer to do, then it balloons to like 4 to 5 times that size. So if we can be thoughtful blockchain engineers, then we can at least prevent this from growing faster than it needs to grow. But of course, as Bitcoin becomes more popular, it's necessarily going to continue to grow. So robustness. I already mentioned testnet. If you can run your application on testnet for several months without breaking, it's probably going to be fine on mainnet. People are attacking testnet all the time. They're forking it. The hash rate is so low that anyone can point miners at it and start doing crazy things. It's of course preferable to have to put out fires in testnet than production, and if you screw up and you lose Bitcoins, definitely preferable to lose testnet coins since they're valueless. I already mentioned sort of the block storms, the reorganization storms on testnet. Even just being able to process 10 blocks per second, which never happens on mainnet. If you can do that on testnet, you'll be fine. Also, have to talk about DDoS. So in Bitcoin, if you haven't been DDoS attacked, you probably just haven't become popular enough. There's actually at least 1 or 2 groups out there that specifically DDoS crypto companies for Bitcoin ransom. And unfortunately, some of them pay the ransom. I think that most of us, especially the larger, more well-funded companies, are able to resist the attacks, though it's usually a major annoyance to us. BitGo got DDoSed most recently, I want to say 2 or 3 months ago, and it happened on a Saturday morning, so wasn't happy for any of us. They specifically attacked us, in the wee hours of a Saturday morning, and asked us for, I forget how many Bitcoins of ransom, which we refused to pay. Finally, transaction malleability, which hopefully will stop being an issue soon, is still an issue. You need to make sure your service is not vulnerable to it. The easiest thing to check here is to make sure that you're not using transaction IDs as like a unique identifier, because that can get changed out from underneath you and potentially result in bad things. I know that Mt. Gox blamed a large number of their withdrawals on malleability back in the day, which, if it was malleability, it was an additional issue of their withdrawal system not checking for that. So a lot of us are interested in Bitcoin because of the trustless aspects of it. The primary purpose of it is that we disintermediate the need for any trusted third parties, but many Bitcoin users and especially businesses are throwing this feature out the window. I prefer for businesses to understand that the cost of running nodes and verifying the blockchain on their own is actually trivial in comparison to the value of their business overall. I know for Satoshi, I pay maybe $40 or $50 a month to have a dedicated VPS, and that's running things on top of Bitcoin. So I would hope that any business, even a tiny startup, would be able to afford that. So one particular example is like some miners, I think this was last year, They lost a number of block rewards because they were not running their full nodes and validating the blocks, and they essentially started creating an invalid chain after a soft fork occurred. Then there was also an issue not long after that with blockchain.info, where people thought that Satoshi was moving its coins. This was quickly shown to be false by anyone who had a full node, because they would just check to see that the transaction didn't actually exist. That particular issue was a bug in the push transaction API, where blockchain.info was not fully validating the transactions before indexing them in their own service. For businesses, I think it's not so much an issue of the resources of running a node. It's really, as I mentioned before, an issue with the indexing options. So if you're running a service, you need to be able to look up data by a number of different attributes that are not indexed by a node. Though I would mention that there are some out-of-the-box solutions like Toshi and Insight that give you a little more flexibility, but even those do not have sufficient customization for our needs, so we have to roll our own when it comes to indexing all of the data. And of course, depending on the query volume and latency requirements for your business, it may not make sense to bother administrating Bitcoin instances in addition to indexing software and databases. A number of smaller startups may just use third-party API with extreme centralization and trusted setup, which could go wrong. But I think that even if there are companies that are using these third-party APIs, like BlockCypher, blockchain.info, what have you, then the least that we can do is to ensure that the third-party APIs are running their own full nodes and only providing data directly from Bitcoin-D instance. So BitGo is a member of the Cryptocurrency Security Standards Steering Committee, and we're working with the overlying organization, the Cryptocurrency Certification Consortium, to help further develop standards around all of this, around how blockchain businesses should validate their data, how they should secure their data and their private keys. And it's definitely clear that the highest level of security certification is going to require you to run your own nodes. So might as well get a head start and run full nodes from the start. So Bitcoin is this completely new paradigm. It throws a lot of users for a loop because it's so different from the traditional system, financial system. Users, I've found, are generally conditioned to expect that if they do something wrong, central administrators will be able to swoop in and unlock their account or undo a transaction that they didn't mean to make. We have probably a decent percentage of our own support cases are due to people who are asking us to undo things that they have done, or recover lost information, recover their backup keys, for example. The average user will not read the manual. They will not make a sufficient effort to secure their own passwords and their own keys. We can force people to jump through security hoops. For example, one thing that we do is if you choose to download your own backup key to secure it yourself, we force you to verify a code from that PDF that is generated before we allow you to start using the wallet. But we still had quite a few people who download it, put in the security code, and then a few months later, they have no idea what this backup recovery key is that we're talking about because they never downloaded it. As a result, for that particular example though, what we've done is we created a key recovery service where you can choose to have your backup key held by a trusted third party. It's not BitGo and it's not you. And if you screw up and lose your password or other credentials or your primary key, then you can take a hit, pay a fee to the key recovery service, and they will go into their vault and get the third key and sign a transaction to recover your funds for you. I've also found that users are not used to two-factor authentication. We get a lot of very low-level questions of, what is Authy or what is Google Authenticator. A lot of people are not using particularly secure passwords, though we do force, at least a sufficient level of complexity there. We even have a lot of users that come to us and assume that we're an exchange, and they ask, how do I send my dollars to you? So that's just like, I think, a good case of people not reading any of the documents. And of course, we have a number of users that their primary language is not English, and we don't have translations for our site, so that can result in a number of communication issues. We've also found over the past year, the full blocks, creating this new fee market has created a number of additional complexities for us as a wallet to ensure that our users are getting their transactions confirmed in a timely manner. You can only get about 3,000 transactions into a 1 megabyte block. And basically what we've seen happen is that you get big spikes, especially on Mondays. Mondays are when everybody, I guess, gets back to work and starts sending Bitcoin transactions. And because everybody's bottlenecked in there, you have to have a responsive fee algorithm that will figure out how you can get to the head of the line if you're willing to pay for it. The transaction fee market has a number of issues that I've seen. Of course, the average user cannot be expected to know what the state of the unconfirmed transaction memory pool is. Dynamic fees, I think, are a step in the right direction, but they're not a silver bullet. We are on our third version of dynamic fee algorithm, and there's still an issue because we can't predict the future. So we can be really close, but you can still have major upticks in transactions on the network that will get your transactions stuck for anywhere from an hour to several days, depending upon how long that it lasts. There is a replace by fee is a new way of working with the fee market, but it actually poses a challenge to us as a multi-sig provider, because we would have to either go back to the user and ask them to send a new signed transaction with higher fees, or get them to pre-sign a lot of transactions up front. It's definitely possible. We just haven't felt the crunch yet that it needs to be, that is a necessary thing. In fact, we're hopeful that child pays for parent, which should be landing, I think, in point 13, will help us automatically, because when our users are creating long chains of transactions that get stuck, we're already bumping up the fees on those to match the current fee market, and hopefully that will get the entire chain of a user's transactions prioritized and mined faster. So we are currently at this state where Bitcoin can only really do about 2 or 3 transactions per second. A lot of us are just holding our breath, waiting for SegWit and Lightning Network to come around. Even with SegWit and Lightning Network, it's only a matter of time before we need to increase the block size, because the blockchain is essentially the anchor layer for all of these second layer transactions. One way to look at it is, I guess, going back to the terms of the UTXO set. While not every transaction should be on the blockchain, we want to be able to get Bitcoins to as many people as possible. And if you want to get a Bitcoin to 1 billion people, that's that's 1 UTXO per person. That's 7 billion UTXOs, and we have, what, 40 million now? And I don't even know how many decades it would take, you know, from a technical standpoint, to get that to everybody. So I'm in favor of both on-chain scaling and off-chain scaling. We need all the scaling that we can get. Hopefully, I think the more capacity the network has, the more people are going to use it. It's kind of like computer hardware in general. I've been using computers since the late 90s, and computers are never fast enough. You know, the faster the hardware becomes, the more the software engineers use the hardware until, you know, we're always on this sort of teetering point, trying to maximize whatever is available to us. So I think the more scaling Bitcoin has, the more usage it's going to get, the more use cases it will be able to support. And then I touched on privacy. Privacy is a fundamental tenet of Bitcoin. You know, if you're familiar with the cypherpunk movement, they really spawned cryptocurrency and a number of cryptocurrencies before Bitcoin that failed. I think that the problem with privacy is that users generally don't care about it. They're not going to go to any additional steps to ensure their privacy. So when we're developing applications, we need to make privacy the default. It shouldn't be a choice, it should just be the default, rather than a series of complex hoops that users have to jump through. I've participated in the Open Bitcoin Privacy Project to help better understand, you know, things that BitGo can do, and this results in, there's a number of different attack vectors which you can, you know, spend a number of hours, if not days, learning about. But you know, potential attackers could be blockchain observers who are looking at the blockchain itself, network observers who are listening to the transactions on the network, even the transaction participants themselves. You know, some particular attacks send tiny amounts of Bitcoins to different addresses to help trace where they get spent. And then there's physical adversaries who try to gain access to your devices, and even wallet providers themselves. If you want to be exceptionally paranoid, really care about your privacy, then you have to worry about the software provider of the wallet, because they may be collecting or leaking, you know, personally identifiable information about you and your activities. One quick note about Ethereum, because I've spent the past few months working with building a blockchain indexer for Ethereum. Ethereum is a completely new beast. The biggest thing that really threw us for a loop was the 256-bit math. And while math in and of itself is pretty simple, most operating systems, databases, CPUs, I think max out at 64 bits. So you may be running database software that doesn't actually support native 256-bit integer math. So if you were trying to, for example, keep track of balance updates and other operations, you may very well end up needing to custom code a solution for performing the math, or at very least storing these huge numbers in a format that works for your service. From what I've seen, I think that a number of the services out there, I know that Ethereum J, for example, doesn't really try to store these numbers as 256-bit. They just store the raw bytes for everything, which makes it easy for storage and retrieval, but not so much for like manipulation and indexing if you're trying to build a wallet service for high transaction volumes. So you may have also noticed that a number of Ethereum wallets or services don't support deposits from contracts. This is because it's a lot more complicated to do so. Essentially, you have to execute the contract locally and parse all of the resulting internal transactions to see like what the balance deltas were from that, to see if any of them resulted in a deposit to an address that belongs to your service. I think I saw something recently where people were having issues with Coinbase accepting contracts, deposits. And of course, we've seen the DAO disaster. We've seen the resulting hard fork. I would say, if Bitcoin, the Bitcoin core developers, and even in the code itself, it says, Bitcoin is experimental beta software. If Bitcoin is beta software, then Ethereum is alpha software. We've just had so many issues trying to use the tools in the Ethereum ecosystem. The good news is that we've seen a lot of progress where, we ping the developers and say, hey, we need to be able to do this, and then a few days or weeks later, hey, now we have that ability. But it's just a lot younger, it's a lot less mature. It's definitely the Wild West from a number of different perspectives. And lastly, the community. So, BitGo has had a number of issues over the years. We're not perfect. We had an issue with a legacy wallet recovery tool that resulted in like an 80 Bitcoin transaction fee due to integer overflow in a library that we had updated in our main code base, but not in our deprecated code base. Thankfully, we ended up managing to get that back by coordinating with Antpool, who graciously returned it. And then we additionally paid that user a 25 Bitcoin bounty for uncovering the bug. This was one of several other issues that resulted in big blow-ups on Reddit. Like when someone found a patent application that we had a year or so ago, we ended up getting trolled really, really hard on Reddit by someone who managed to convince a lot of people that we were trying to patent multisig. After reading the patent, I could understand how you would come to think of that because there was so much legalese, it's hard to even understand what's going on. To clarify though, the patent was for a specific process of setting up disparate, like 3 disparate machines, and then generating the keys to the 2 out of 3 key wallet on these 3 disparate machines. Also, it's not even a patent, it's a patent application which may never be granted, though we very quickly afterwards mentioned that we were adopting the Twitter Patent Innovators Agreement. So essentially, we're not going to be patent trolling anybody for this or any other Bitcoin-related stuff. We're not interested in patents. In fact, we hate patents. Our CEO has written a number of blog posts over the years about why patents are terrible, but unfortunately, the world is what it is. Let's see, there was also an issue uncovered with change output privacy, and we're now randomizing the change outputs, but even now this is an imperfect solution because P2SH is only about 10 to 20% of Bitcoin transactions. So a lot of our users who are going in between pay to public key hash and pay to script hash, it's blatantly obvious which outputs are the change outputs because you look for the ones that start with a 3 versus addresses that start with a 1. Unfortunately, that's sort of a privacy issue that we can't get around at the moment. Those, and of course the Bitfinex hack, which unfortunately, because we still have not published full post-mortem of the incident, and I've actually been on vacation for the entire thing. So,
very convenient.
Yeah, I haven't had much input or really been roped into all of that. But of course, the initial assumption from everyone was, oh, BitGo screwed up big time, and their service failed, and we were blindly signing transactions. And while I can't say anything additionally, I can say, it should be clear from the fact that none of our other thousands of clients had this issue happen to them. So it was something very specific to Bitfinex and their integration that created a security flaw. And as you can see, this is how I feel a lot of times when I go onto Reddit. For the first 8 years that I was a software engineer, I actually worked for an email marketing company, which is basically legal spamming. I would receive the occasional angry email from someone who received, marketing emails that they didn't want to get, and usually they didn't know how to hit the unsubscribe link. But while I would only get 1 or 2 angry emails a day from sending 100 million emails a day out to the world on behalf of customers. With Bitcoin, it's a very different beast. There's a lot of people in the community with very strong views, and they're happy to let you know them. And I've definitely received more vitriol in the past year or so as a Bitcoin ecosystem developer than I did in almost a decade of being a professional spammer. So you just got to have a really thick skin, especially as you're building these services. Things are going to go wrong. Hopefully they won't be catastrophic for your service, but you're going to end up with a lot of pissed off people, and you have to develop a very thick skin because a lot of trolls are going to descend upon you. So I've been a Bitcoin enthusiast for about 5 years now, a Bitcoin engineer for 18 months. It's been a wild ride, and I think that we're just getting started. So thank you for hosting me, and I'll try to answer any questions that I'm able to.
Before we start with the questions, I have to interrupt the Bitcoin Magic just for 1 minute, because we are fortunately many more than we expected. So I will ask for a poll for ordering some food. We had a lot of pizza recently, so we will order some Chinese food. So who is in for some random selected, centrally and trust-based selected Chinese food? Say one, okay. Sushi, Chinese/Japanese sushi. Okay, up again because I didn't count it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18, so 18, raise your hands for pizzas. Are you sure you cannot eat some? Okay.
Pizza sushi.
So 18.
Pizza sushi. Pizza with sushi. No.
So 19 Chinese less sushi portions. The ones that didn't raise any hand will not eat anything, right? Okay, so we will we order for custom aggregates of some kind of food.
Can you ask for a
Beer.
Beer.
Yeah, and Chinese and beer. Yeah, Chinese and beer. We will ask you for cash after we will pay in a centralized way. Okay, so let's say 19 portions of Chinese food. I will do that. I will, yeah. And
Facciamo 20.
let's say 20 food portion, and then I will start to ask for tanto prova e io inizio a chiedere un po' di questions. Okay, so we have some question from home, from Lawrence. Lawrence, do you want me to read it, or you want to get some voice on Skype? Okay, I will ask it. So the first one regards the patent issue. So after you say that Bitcoin is not going to use the patent for patent trolling or for offensive strategy, Lawrence wanted to ask you if Bitcoin can somehow guarantee that in eventuality of new acquisition of the company or failure or whatever, the patents could not get in the hands of patent trolling. And I will add, since Lawrence is asking, I recently knew about the Blockstream defensive patent strategy, and I'm curious if you discussed it internally, if adopt that or not, or a different one.
So my understanding of the agreement that we have adopted is that regardless of what happens to the company, the patent will retain ownership by Mike Belshoot, who is the creator of it. Now, I know that we were discussing, defensive patent pools back a year ago, and they sounded fairly receptive to it. I don't know, I guess the Blockstream news just happened in the past, month or two?
Yeah.
So, while I was on vacation. But I believe that we would be receptive to it. Of course, I would have to ask Mike. He is the creator, inventor. But once again, the whole thing is that it's not even a patent. It's a patent application, and I don't know if it'll ever become a patent. So if it became a patent, then we could start talking about, we should put it into a pool.
Well, I think that the pledge to not use it aggressively could be signed also for applications. But maybe, since you answered that, we could try to propose to Mike some kind of stripes for.
I mean, like I said, he hates patents, and I've talked to him personally about it. So I have no reason to believe that we wouldn't be receptive to such more legally structured defensive patent.
Very cool. Thank you. Other questions?
From what I understood, you don't want to say more about the Bitcoin hack.
Right.
So, but what do you think? Is it going to be made public? What happened there? Are we going to be aware? What is your opinion? Because I think it should be published in order for other people, other exchanges to protect themselves. It's good for the community, for all.
Oh yeah, I mean, I think that good security protocol, especially for an open community, is that you publish a post-mortem. So I think I've pinged them a few times about it, and basically the response that I get is that while there is an investigation ongoing, they're not going to publish the post-mortem. Unfortunately, I have no idea how long it will be ongoing. So I will tell you that as soon as I know the investigation is concluded, I'll definitely be pushing for a post-mortem. I think everyone deserves to know.
Cool. Also, getting back to the slide about privacy. You said that you joined a privacy-oriented group, researching group. Can you disclose some more details about this project? If it's still running, if other companies can join? Yeah,
so it is. It's open for anyone. The Open Bitcoin Privacy Project. It's headed by Christoph Atlas, Justice Schwanvier, I think a few other guys. If you Google it, it should come up. I think generally they're trying to do a round of wallet reviews at least once a year, and they have a whole slew of exhaustive criteria. So anyone who wants to, especially if you run a Bitcoin wallet, if you want to get judged or get on the next round of reviews, they do a very simple participatory model where you become a reviewer and you review another wallet, and they will have several people that review your wallet. So I did this last year. I would say it takes maybe 2 hours to go through the entire process. It's a checklist of probably 50 different things where you're looking at the wallet, seeing what the features are, and then you're actually testing them, creating Bitcoin transactions, figuring out certain aspects of how the wallet operates, with regard to network and UTXO set.
So it's a legal entity, or it's just an open source project?
It's just an open source project as far as I know.
So every project there are. And does the same apply to the security standard group that you mentioned in the slides. So it's not just US based, it's a global security standard community.
As far as I know, it's also fairly open. You know, there's a technical steering committee that has, I want to say, a half dozen or so different companies on it. It's, you know, it's an attempt at creating a standard. You know, there's no legal, force behind it or anything. I'm hopeful that it will, it will become something that services aspire to have, certification, level 1, 2, 3, 4, what have you, just to give more ease of mind to their users.
Could you talk a little about the state of Bitcoin core development? Do you feel that it's moving at a sufficient pace for BitGo, for Bitcoin?
Yeah.
Like it's a channel.
So,
can you repeat the question?
Yeah, the question was talking about sort of the pace, the progress of Bitcoin core development. It's never going to be fast enough to make everybody happy. There are a number of challenges. I think the biggest challenge is that it takes a lot of experience to get to the point where you can be a competent Bitcoin core developer. So, it was great to see Matt Corallo. I think he's going to be going to New York and trying to sort of bootstrap some more people, to get them into the knowledge, the expertise. Up until now, I don't think we haven't really had that type of outreach. But now Bitcoin is growing to the point where we have more money, more venture capital in the system to hopefully help us try to bootstrap ourselves. From an industry standpoint, of course, there's a lot of contention because you have very different viewpoints and needs and use cases. And so you have this one fairly small team of mostly volunteers, and they have their vision for Bitcoin. And then you have the rest of the world, and everyone has their own vision for Bitcoin or their own use cases that they're trying to facilitate.
I guess, like, would BitGo consider this fund? Do you guys fund or participate at the level of supporting the core development? Or
right.
Is it sort of like a...
I've asked in the past, would we ever want to hire a core developer?
Yeah.
And generally the answer that I get is, when we're a little bit larger, because we've still only got about 15 employees. Yeah. Though, as I mentioned, we've spent a lot of time on our dynamic fee algorithms, and those, as a large part of the algorithm, use the dynamic fees from Bitcoin Core. But we've actually found, and I've had some conversations with Alex Morkos, who is the primary dev for the fee algorithms. We found that much like the UTXO selection issue, you're trying to optimize for different things. So there was a change in point 12 to the fee estimate algorithm that we found was actually not good for us. So we actually have a slightly tweaked version of Bitcoin Core that we found works better for us. And in fact, I think I've done a little bit of dabbling with Satoshi and had a few minor documentation and testing changes, pull requests into Bitcoin Core, but I think that if I get to the point where I'm going to start contributing, I'll probably be working on the fee estimate algorithm stuff and making it more flexible. I'm really hopeful that I can get into that by the end of the year. But that kind of comes back to the fact that you've got the cypherpunks, and then you've got industry. I see those as two major different viewpoints, and it's really hard to get cypherpunks, I guess, to see some of the pressure that industry has. So I think the more industry needs to go in and start trying to make our own contributions, and hopefully they'll get accepted.
About the future of BitGo, like dynamic key and also blockchain indexing that BitGo developed, how much is open source? How much will be open source?
So I believe we open source most, if not all, of our front-end code and our SDK. I believe we open source pretty much everything except for our key server signing stuff and the indexer and the back-end sort of platform logic, like what actually powers our API. I believe the justification there is that the SDK and the front end stuff is what is actually using your private keys to sign stuff and then ask us to countersign it. So that sort of gives more trust that we're not trying to do anything nefarious. Even if we open sourced our indexer or our platform code, I'm not sure it would be very helpful to many people. It's highly customized for our specific solution. But we are always looking for more, I guess, SDK languages. I think we just put out a PHP version of the SDK because there was so much demand for it.
Is there some representative from BitGo in the natural workshop you cite? The natural workshops? Are you going or?
So I was in Hong Kong, and then I should be back here in October. I'm not sure if anyone else is going to be joining me though.
Which kind of database are you using inside? You mentioned MySQL or any NoSQL solution, which is specific to BitGo.
Oh, so we use a couple of, they're all key value stores, but our primary, most of our stuff is Mongo. So that allows us to scale pretty easily. It's been interesting for me from the scaling standpoint, because before this I was working with really large HBase and MapReduce HDFS clusters, thousands of machines, because we were sending hundreds of millions of transactions, emails. But Bitcoin is just so tiny. I mean, when the entire network can only do 2 or 3 transactions per second, scaling your local stuff is pretty trivial. I mean, throw a few machines at it, and unless you get DDoS or something, you're going to be fine.
So you have a private infrastructure, not Amazon or Google or something like that?
No, most of our stuff is geographically dispersed AWS. And then we end up having to use other protections for DDoS attacks, but it makes it a lot more flexible. We don't need to have private, secure, standalone metal boxes that we build stuff on, because we don't keep any private, unencrypted private keys on them. We do have a special hardware key signing device for our own keys, but the entire idea behind our infrastructure is that even if our keys got compromised, then the other keys are elsewhere. So hopefully no one uses them up.
Other questions? No more questions. Okay, so thank you very much, Jameson. So you, we will ask you to let us 20 euros. I know it's a little expensive, but it's a random bunch of tu hai già pagato per loro due.